Welcome back to the Deep Dive. We are really excited today to rip apart some fascinating source material and hopefully build you that fortress of knowledge we always talk about. The goal, as always, is making sure you don't just hear the facts, but you really grasp the deeper implications of what's happening, especially in tech. And today, yeah, we're accelerating straight into a huge one. Tesla's full self-driving system, FSD, specifically the massive leap that version 14 seems to represent.
Right, and the whole conversation just got amplified, let's say, by this really audacious claim from Elon Musk. Classic Musk, really.
Totally. October 7th, 2025, he just drops this bombshell. FSD version 14.3, he says, will make the car feel, and this is the quote, sentient.
Sentient. I mean, what a word choice, right? It's brilliant marketing. You can't deny that.
But beyond the immediate, is this just hype reaction, it does point towards something genuinely new on the technical side. Okay, so you think there's fire behind the smoke?
I think you have to look at the engineering shift required for them to even consider using a word like that, even metaphorically. We're talking a radical change in architecture, mainly this deep dive into reinforcement learning. That's what makes this more than just talk.
Got it. So that's our mission for you today. We're going to unpack this. First, what does sentient actually mean when we're talking about AI? The sources are calling it proto-sentience, which sounds interesting. We'll look at the user experience, what it feels like.
And why that feeling matters psychologically.
Exactly.
Okay.
Then we need to pop the hood, right? Get into the engine room. How does reinforcement learning actually work here? What's this logic of rewards and penalties?
And Tesla's specific kind of hybrid approach to it.
Right. And after that, we'll look at the numbers. The quantifiable leap. FSD v13 compared to v14.2. We're talking parameter counts, this mixture of experts thing.
Yeah, the MOE architecture is key.
And finally, we have to put it in context. The big picture. Tesla's vision-first approach versus the very different strategy of its main rival, Waymo. What does this all mean for the robotaxi future everyone's racing towards?
It really is like watching AI evolution and fast forward, isn't it? Moving from, just following rules to something that seems adaptive, thoughtful, almost, on the road.
Okay, let's jump into part one then. This word, sentience.
Oh.
So sentience, most people hear that and think, consciousness, self-awareness, feelings, subjective experience. Is that what Tesla's claiming? Or is this just Musk being Musk, using a loaded term for effect?
Well, we definitely need to ground ourselves in what the sources suggest Tesla means here. And it's not consciousness in the philosophical sense. They're not saying the car has a soul or feels emotions.
Okay, good. That would be a stretch.
Yeah, just a bit. The term they're using, or that the analysis uses, is proto-sentience. The idea is that the AI's behavior becomes so fluid, so context-aware, so sophisticated in its decision-making.
That it feels like it's aware.
Exactly. It behaves in a way that our human brains, naturally interpret as intentional, as aware. It's less about the machine's internal state and more about how its actions convince the driver that it understands the situation, the intent behind things, not just the raw data points.
That makes sense. It's about the perception it creates. And what's really interesting is why Musk made this claim when he did. It wasn't some internal memo leak. It was a reaction to a user's experience.
Right. That's a crucial detail. It tells us what this feeling actually looks like in practice. The whole thing blew up because of a tweet from a Tesla enthusiast, Zach, who goes by at BLKMDL3 online.
Okay, I think I saw that thread. He was testing v14.1.
Yes, and reporting just incredibly positive results. The headline was 0 disengagements across 10 really complex drives. But the key phrase he used wasn't just, it worked well. He said the car felt human aware.
Human aware. That's different from just automated, isn't it? What did he point to? What made it feel that way?
He talked about complex social driving situations, things like smoothly navigating construction zones where actual humans were directing traffic, handling tricky parking garage ramps. But the most striking example was how it seemed to, quote, read gestures from traffic workers.
Read gestures, like a hand signal.
Yeah, think about it. A construction worker gives a subtle wave, maybe a slight head nod, telling you to merge or hold back. That's not an official road sign. It's nuanced, implied human communication.
And usually that's where automation gets stuck, right?
Okay.
Ambiguity.
Exactly. A purely rule-based system might just freeze or disengage. But Zach was saying v14.1 processed that visual cue, seemed to interpret the worker's intent, and then just smoothly did what was needed. That feels like understanding, not just code execution.
Okay, I can see how that would feel different. If the car isn't just following hard rules, but seems to grasp the unspoken language of the road?
That's the leap. It's calculating the probability of that gesture's meaning based on massive RL training and reacting fluidly. It's the difference between rigid automation and, well, intelligence.
And that positive feedback, that human-aware comment, that's what prompted Musk to up the ante.
Seems like it. He'd previously teased that v14.2 would feel almost like a sentient being. But after Zach's report on v14.1, he jumped straight to promising actual sentience by v14.3. The sources suggest this might reflect, really rapid internal progress, maybe faster than they even expected, validating this new approach.
All right, so if the goal is this feeling, this proto-sentience, what are the concrete features in v14.1 and looking ahead to v14.2 that actually create that experience for the driver?
It seems to be about adding layers of personalization and subtlety. First up, dynamic speed profiles.
Okay, what's that?
Older FSD versions could feel a bit robotic. They followed the rules, sure, but lacked that human touch, that nuance and speed and spacing. Now, you can apparently choose a driving style. We know about sloth mode.
Sloth, seriously.
Ha, yeah. Sloth mode prioritizes extreme caution, maximum comfort, lots of following distance, very gentle maneuvers. Then there's hurry mode.
Let me guess, more assertive.
Exactly. Assertive, efficient in traffic, closes gaps more readily, but still, crucially, within safety limits.
So the car starts to mirror your mood or your preference for that trip. If I'm feeling cautious, I pick sloth. If I'm running late, maybe hurry?
That's the idea. And the sources hint there might be more modes coming, like Zen or Sport, offering even finer-grained control over the car's driving personality. This customization is huge psychologically. It makes the machine feel like it's adapting to you instead of you constantly having to adapt to it.
Okay, that's a big step towards feeling less like a machine. What else gives it that thoughtful chauffeur vibe the sources mention?
Context-aware arrival options. This is really clever. See, arriving isn't just about hitting a GPS pin. A human driver knows that.
Right. You need to park or find the drop-off, or maybe look for charging.
Precisely. And V14 aims to do that thinking for you. Based on the destination type and the real-time environment, the AI decides the best way to end the trip. Is it a place with chargers? Okay, it'll actively look for one. Is it marked as a quick drop-off zone? It'll pull up curbside efficiently. Residential. Maybe it starts hunting for parking immediately. It's anticipating the purpose of your arrival.
Acting on implied intent again. And this must tie into the vision system's capabilities too.
Absolutely. This is where the vision-based detours and adaptability really shine. Remember, Tesla ditched radar and LiDAR. It's all cameras now.
Which seemed crazy to some people.
It did, but V14 is where they're trying to prove that bet pays off. Older systems and many competitors rely heavily on these super detailed pre-made HD maps. If something unexpected happens, a sudden road closure, bad accident, flash flood that isn't on the map yet.
The system gets confused. It just gives up.
Often, yeah, it needs the map update. FSD V14, though, is designed to see the unexpected blockage with its cameras, the construction barriers, the police tape, whatever it is, and just reroute. Adapt on the fly, based purely on visual input, without waiting for a map layer to confirm it.
That real-time visual adaptability must feel incredibly competent to the driver, like it's actually perceiving the world.
That's the goal, and it connects to the final piece, micro-smooth UI responses. It sounds minor, but it adds up. Things like instant confirmation when the brakes are applied, no lag when shifting from park to drive.
Reducing friction, basically.
Exactly. Removing those little hesitations and delays that remind you you're dealing with software. Testers keep mentioning this robotaxi vibe. The system handles complex maneuvers, navigating tight garages, identifying loading zones, waiting patiently at gates with a kind of quiet confidence. It makes the driver feel more like a supervisor of a capable system rather than, a beta tester constantly on edge.
And that seamlessness, that perceived competence, that's the foundation. That's what builds the trust needed for people to eventually let go of the wheel entirely.
Precisely. It's the bedrock upon which the whole robotaxi vision rests. And it leads us right into how they're technically achieving this smoothness and adaptability.
Okay, so if that feeling, that proto-sentience, is the goal, then reinforcement learning RL is the engine driving it. And you said this is the really big technical shift in FSD v14, moving beyond just copying humans.
It really is the critical pivot. You have to understand, earlier FSD was built mostly on imitation learning.
Which means?
You feed the AI just mind-boggling amounts of video data.
Yeah.
Millions of miles of humans driving. And you basically tell the AI, watch this, learn to do what the humans did.
And that worked.
Up to a point.
Oh, yeah, it built an incredible baseline. It taught the AI how to handle, say, 95% of normal driving scenarios pretty well. The problem is it also learned our human flaws.
Like hesitation. Or braking too hard sometimes. Exactly. Hesitation, jerky reactions, inefficient lane changes, sometimes even unsafe habits. And crucially, imitation learning struggles when faced with something truly weird, an edge case that just wasn't common in the training videos. It doesn't know why the human did something, just that they did it.
Right. It can copy, but doesn't necessarily generalize or optimize.
Precisely. And that's where RL comes in. RL isn't about copying. It's about learning through trial and error, guided by consequences to achieve a specific goal, maximizing performance.
Okay, break that down for us. How does RL actually work in the car?
Let's simplify it. You have the agent, that's the FSD neural network, the AI brain. It exists in an environment, the road, traffic, weather, pedestrians, rules of the road, everything.
Okay, agent is AI, environment is the world.
Right. The agent perceives the current state of the environment, where it is, what's around it, how fast it's going. Based on that state, it takes an action, accelerate, brake, steer left, steer right.
Standard driving stuff.
Yes. But here's the key difference. After taking an action, the agent receives feedback in the form of a reward or a penalty.
Like points.
Kind of. Positive points are rewards for good outcomes. Maintaining smooth speed, merging safely, stopping gently at a light, staying centered in the lane. Negative points or penalties for bad outcomes. Sudden braking, getting too close to another car, jerky steering, causing an intervention.
So it's constantly trying to get the highest score.
Yeah.
By figuring out which actions lead to the biggest rewards and fewest penalties in any given situation.
Exactly. It runs, essentially, trillions of virtual experiments, both in simulation and learning from real-world driving, to discover the sequences of actions that mathematically maximize that cumulative reward over time. It's optimizing for the best possible driving performance according to the goals set by the reward function.
And this leads to what you called emergent intelligence.
Yes, this is the fascinating part. Because the AI isn't being explicitly told how to achieve the goal, just what the goal is, maximize reward, it can discover strategies that no human engineer ever programmed.
Like what? Give me an example.
Maybe subtle things, like learning the exact tiny bit of lane positioning that encourages a hesitant car to merge behind you instead of cutting you off. Or figuring out the perfect acceleration profile to catch a sequence of green lights down a long avenue. These aren't hard-coded rules. They emerge from the optimization process.
Wow. So it's learning the art of driving, not just the mechanics.
That's a great way to put it. It's this emergent, nuanced behavior that allows v14 to handle those complex, ambiguous situations, like the construction worker's gesture, with more fluidity, rather than just defaulting to a super conservative, rigid action.
But you mentioned Tesla uses a hybrid approach. They don't just throw out all the imitation learning data.
No, and that's smart. They use that massive data set, billions of miles of real human driving, to give the AI a really strong starting point. It's like, here's how humans generally do it. That gets the model 95% of the way there very quickly.
Okay, so imitation provides the foundation.
Right. Then RL comes in as the refinement layer, the optimization engine. Its job is to push performance beyond the human baseline towards better than human levels. RL is specifically tuned to identify and smooth out those inherited human weaknesses, the unnecessary braking, the slight hesitations, while relentlessly maximizing safety and comfort and efficiency all at once.
It's learning to be not just a safe driver, but an excellent driver.
Yeah.
Smooth, confident, efficient.
That's the target. And this continuous improvement cycle, this self-learning capability, is only really possible because of Tesla's unique advantage scale.
The collective intelligence on wheels, as the sources put it. Millions of cars constantly gathering data.
It's their trump card. Every Tesla with FSD enabled is a sensor platform, constantly feeding data back. But the most valuable data for RL training actually comes from failure or near failure. It comes from the shadow mode feedback loop.
Explain shadow mode.
Okay, so shadow mode runs silently in the background while a human is driving or supervising FSD. The crucial bit is when the human intervenes. The moment you grab the wheel, hit the brakes, or nudge the accelerator because you feel the AI isn't handling things right.
That's a disengagement.
Right. And the system flags that intervention immediately. It records a clip of sensor data, video, speed, steering angle, everything leading up to and including that intervention.
So every time a human takes over, it's basically saying, hey, AI, you messed up here.
Essentially, yes. That intervention is treated as a high-value training signal. It's like a powerful negative reward, a penalty. That data clip gets sent back to Tesla's servers.
And used to teach the AI.
Exactly. It becomes a targeted training example for the RL model. The engineers analyze it, maybe recreate it in simulation, and use RL to teach the AI. In this specific tricky situation, the human took over. This is the safer, more optimal way you should have handled it.
So the global fleet is constantly identifying its own weaknesses and teaching itself how to fix them. That's powerful.
It's a self-correcting learning loop on a planetary scale. Every tricky intersection, every weird pedestrian behavior, every confusing construction zone encountered by any Tesla anywhere contributes to making the entire fleet smarter over time.
Processing all that data, though, petabytes of video, interventions, running simulations, that must require insane computing power.
Absolutely insane. And that's where Dojo comes in. Tesla's custom-built supercomputer.
Right. They built their own because off-the-shelf stuff wasn't good enough.
Pretty much. Dojo is specifically designed for the massive task of training these huge neural networks, particularly processing video data and running these complex RL simulations at scale. They can take those shadow mode intervention clips, create high-fidelity virtual versions, test the AI against them relentlessly in simulation.
Hammering out the edge cases virtually before deploying back to the real cars.
Precisely. It's this constant loop. Real-world data identifies problems. Dojo simulates and trains solutions. Updated AI model goes back to the fleet. You couldn't do that efficiently or quickly enough using standard cloud computing. Dojo is non-negotiable for the speed and scale of development needed for something like FSD v14.
Okay, let's circle back to the reward system nuance. You said RL is trying to maximize rewards, but how do they actually tune that reward function to get the behavior they want, to get that proto-sentient feel? It can't be simple.
Oh, it's incredibly complex. It's what AI researchers call a multi-objective optimization problem. You're juggling competing goals constantly.
Like safety versus speed, or smoothness versus efficiency.
All of the above and more. They have baseline rewards, sure, like maybe plus 20 points for a really smooth, gradual stop at a red light.
Right.
But a sudden, jerky stop, that might trigger a big SOA 50 penalty based on the G-forces belt.
So it learns not just to stop, but how to stop comfortably.
Exactly. It's optimizing for the quality of the action, not just the action itself. Safety always has the highest implicit weighting, huge penalties for collisions or near misses, obviously, but comfort and efficiency are layered on top.
And this is what defines the driving style we talked about earlier, like sloth versus hurry.
Absolutely. Those different modes likely have slightly different weightings in their reward functions. Sloth mode might give higher rewards for maintaining larger following distances, while hurry mode might slightly reward more efficient gap closing within safety bounds.
But for V14, you're saying the rewards go beyond just physical maneuvers into social intelligence.
That seems to be the key evolution for V14, yes. They're apparently building rewards for successfully navigating social cues. For example, maybe the AI gets a small reward for correctly anticipating a pedestrian's likely path based on their head movement or body language before they even step into the road, allowing for a gentle, preemptive slowdown.
Wow. Rewarding prediction of human intent.
Right. And conversely, penalties if it does something socially awkward or unsafe, like forcing another driver to brake hard because it merged too aggressively, or failing to yield when a human driver clearly has the right of way based on subtle cues, not just strict rules.
So they're actively training the AI to understand, or at least convincingly mimic understanding, the unwritten rules, the social fabric of driving.
That's the goal, rewarding behavior that feels polite, predictable, and aware. This focus on rewarding social intelligence, anticipation, and smoothness, that's the bridge from just being automated transport to feeling like something more, something approaching that proto-sentient behavior.
Okay, that makes the technical challenge much clearer. And it sets the stage for understanding the scale of the changes needed from V13 to V14. So this shift to deep RL, rewarding social intelligence,
Yes.
it sounds computationally expensive. You can't just run that on the same software and hardware backbone as before, right? The sources must talk about a major architectural upgrade.
Oh, absolutely. The leap from FSD v13 to v14 is enormous, technically speaking. It really underscores why they're using dramatic language like sentience. It's not just tweaking the old system, it's a fundamental rebuild in many ways.
Let's start with the brain power, the parameter count. How big was V13 and where is V14 heading?
FSD v13 was already complex, running an end-to-end neural network with roughly 1.5 billion parameters, which is a lot.
Okay, 1.5 billion. Sounds big.
It is, but FSD v14.2, the projections are staggering. We're talking somewhere in the range of 5 to 15 billion parameters.
Oh, okay, that's potentially a 10x increase, 5 to 15 billion. How is that even possible in a car?
That's the core challenge. You need that massive scale to encode all the nuances learned through RL, all the complex reward functions, the vast library of edge cases from shadow mode. But you're right, you can't just make the old network 10 times bigger and expect it to work.
Why not? What breaks?
Latency. The inference time, how long it takes the AI to process sensor data and make a driving decision. With a single monolithic 15 billion parameter network, the computation time would be way too long. You'd crash before the AI decided to break.
Okay, deadly problem. So how do they manage that complexity? How do you get the benefit of 15 billion parameters without the crippling latency?
This is where the major architectural innovation comes in. The mixture of experts, or MOE, framework.
Mixture of experts. Sounds intriguing, like a panel.
That's a perfect analogy. Instead of having one giant brain trying to do everything all the time, MOE works like this. You have a large number of smaller, specialized expert networks. Each expert is trained to be really good at a specific type of driving task or environment.
Like one expert for highway cruising, another for complex intersections, another for parking?
Exactly. You might have experts for merging, for handling roundabouts, for predicting pedestrian behavior, for interpreting construction zones, for navigating bad weather. Dozens, maybe hundreds of them.
Okay, so you have all these specialists. How does the system know which one to use?
There's a gating network, a kind of smart router that looks at the current driving context. Where are we? What's happening? And very quickly decides which handful of experts are most relevant right now. It then activates only those few experts.
Ah, I see. So if you're just cruising on a clear highway, maybe only the highway cruising expert and the long-range perception expert are active. The intersection expert is sitting idle.
Precisely. But as you approach a busy city intersection with pedestrians and cyclists, the gating network instantly activates the intersection navigation expert, the pedestrian prediction expert, the cyclist interaction expert, and maybe a short-range maneuvering expert.
So the total number of parameters is huge, 5 to 15 billion. But the number being actively used for any single decision is much, much smaller.
Exactly. That's the genius of MOE. It lets you have the representational power of a massive model capable of handling incredible complexity while keeping the active computational load low enough for real-time inference speeds in the car. It's what makes scaling to billions of parameters feasible on current, albeit advanced, hardware.
That's a really significant architectural shift. What about memory? You mentioned human-like anticipation requires looking further back in time.
Right. Another key improvement is extended temporal context windows. Think of it like the AI's short-term memory. FSD v13 had a relatively short memory, maybe remembering and processing inputs from the last 2 or 3 seconds effectively.
Which makes it more reactive, responding to what's immediately visible.
Yes, it leads to a more reactive driving style. It sees something, it reacts. v14.2 significantly extends that window. It can integrate information and events that happened maybe 5, 10, even 15 seconds ago into its current decision-making process.
Give me a practical example. How does remembering something from 10 seconds ago make driving safer or smoother?
Okay, imagine you're waiting at a busy 4-way stop. A big delivery truck goes through the intersection from your left, blocking your view of the far side for a few seconds. Just before the truck blocked your view, you saw a cyclist approaching the intersection from that far side.
Okay, got it. Truck blocks view, cyclist was coming.
A system with a short context window might effectively forget about the cyclist while the truck is blocking the view. Then, when the truck clears and the cyclist suddenly reappears right in front of you, the system might react with a sudden hard brake.
Because it's treating the cyclist as a new event.
Right. But v14.2, with its extended temporal context, remembers the cyclist entering the scene 10 seconds ago. It maintains a prediction of the cyclist's likely path, even while obscured by the truck. So as the truck clears, the AI has already anticipated the cyclist's position and planned its own movement smoothly around them, perhaps waiting an extra moment or adjusting its starting acceleration.
That's actual foresight, not just reaction. That feels much more human-like.
It's a crucial step towards proactive rather than reactive driving. It's necessary for handling complex, partially occluded scenarios safely and smoothly.
Okay, architecture and memory makes sense. Let's talk performance targets. FSD v13 was already claiming to be safer than average human drivers. What's the goal for v14.2?
The targets are, well, ambitious to say the least. If V13 was aiming for, say, 2 to 3 times safer than the human average, v14.2 is reportedly targeting 2 to 3 times safer than V13.
Wow. So compounding safety improvements, aiming for truly superhuman levels of reliability.
That's the goal. And the key internal metric they're watching closely, according to the sources, is a 50% reduction in disengagements compared to V13.
Having the number of times a human feels they need to take over, that would be a massive validation of the new RL and MOE approach.
Absolutely. Fewer disengagements mean the AI is handling more complex and ambiguous situations correctly on its own, which builds confidence and directly reflects the improved intelligence and reliability.
What specific new behaviors or capabilities contribute to this safety jump?
There are improvements across the board. On the input side, they're apparently integrating a faster 48 Hz camera input pipeline. Higher frame rate means smoother perception, less motion blur, better tracking of fast-moving objects.
More data, cleaner data, coming in faster.
Right. Then, on the output side, the predictive capabilities are getting sharper. V14 is expected to have much better pothole and debris avoidance. It's not just staying in the lane, it's actively scanning the road surface ahead and making micro adjustments to steer around hazards smoothly.
That requires really high-resolution perception and prediction.
It does. And then there are these more reactive safety systems embedded within the architecture, like the escape velocity protocols.
Escape velocity, what's that, like hitting warp speed?
Not quite. Think of it more like pre-programmed emergency reflexes. These are highly optimized, super fast subroutines within the MOE framework. They get triggered instantly if the system detects a very high probability of an imminent dangerous situation based on specific sensor signatures.
Like a car slamming on its brakes 2 cars ahead.
Exactly that kind of thing. If the sensors pick up that rapid deceleration signature chain, an escape velocity protocol might kick in before the main planning network has even fully processed the entire complex scene. It could trigger maximum safe braking or a slight evasive steering maneuver immediately to break the chain reaction of a potential pileup.
It's like an AI flinch reflex.
Instantaneous, pre-calculated safety maneuvers for critical situations. Okay, that makes sense. All of this, the scale, the memory, the proactive avoidance, the reflexes, it really sounds like they're pushing hard for full autonomy for the robotaxi dream. Are there features specifically pointing towards that?
Definitely. You start seeing features explicitly designed for a future where the car operates without anyone inside. The sources mention golden path visualizations.
Golden path.
Yeah, the idea seems to be that for certain routes or in certain upcoming unsupervised modes, the system might display a visualization of the highly optimized path it intends to take. This is likely designed to build driver trust, showing them the car's plan in advance.
Okay, a confidence builder. What else? The big one is the reported implementation of Banish.
Banish, like tell the car to go away.
Pretty much. It's described as a remote car dismissal feature. Imagine your robotaxi drops you off. You hit Banish on your app, and the empty car drives itself away, maybe to a charging station, a parking spot, or its next pickup, without you needing to supervise it.
Okay, that requires serious autonomous capability. Why couldn't an older FSD version do that?
Because driving away unsupervised often means navigating incredibly complex environments, crowded pickup zones, chaotic parking lots, unpredictable pedestrians wandering around, other confused drivers. It's not just highway driving. To handle that safely and reliably without a human safety net requires the kind of robust adaptive intelligence that V14, with its MOE and deep RL training on millions of edge cases, is designed to provide. V13 likely just wasn't reliable enough for that kind of zero-occupant operation in complex zones.
Right. The liability is huge if an empty car causes an accident. So Banish really depends on V14's smarts. Okay, last piece of this puzzle. Hardware. This massive jump in parameters, the MOE. Surely it needs more horsepower.
It absolutely does, and this is a really important point. The initial rollout of FSD v14.1 and the expectations for v14.2 are primarily for hardware for HW4 vehicles.
HW4 being the latest generation of Tesla's custom FSD computer.
Right. HW4 offers something like a 5x compute performance advantage over the previous generation, HW3. Trying to run a 5 to 15 billion parameter MOE model with all the complex real-time inference it requires is simply too demanding for HW3 to handle optimally.
So if you have an older Tesla with HW3, you might not get the full V14 experience, at least not initially.
That's what the sources strongly suggest. They might eventually release a version for HW3, but it would likely need to be a detuned version, maybe with a smaller parameter count or fewer active experts, meaning it wouldn't have the full proto-sentient capability or the same level of performance as the HW4 version.
Wow. So this is really the first time we're seeing a major FSD software capability explicitly tied to needing the very latest hardware generation. It really drives home how computationally intensive this new RL-driven MOE-based approach is.
It marks a clear line in the sand. The quest for sentience, or at least convincingly intelligent behavior, requires bleeding-edge compute.
Okay, so Tesla's pushing towards this feeling of sentience with FSD V14, driven by vision, RL, and massive scale. This really throws the spotlight on the other major player in the autonomous space, Waymo, and how fundamentally different their approach is.
It really does. It's like watching two different species evolve to solve the same problem, autonomous driving, but using completely different strategies and philosophies. Both are using advanced AI, both are using RL to some extent, but their core bets are just worlds apart.
Let's frame that difference again. You said Tesla is betting on scale and adaptability, using vision only. What's the Waymo philosophy?
Waymo is all about certainty and containment, achieved through redundancy. That's the core idea. Their vehicles are loaded with sensors, not just cameras, but multiple types of high-resolution LiDAR, sophisticated radar systems, plus something like 29 cameras all around.
Creating a super detailed, multi-layered 3D map of the world in real time.
Exactly. They fuse all that sensor data together to build an incredibly high-fidelity, redundant picture of the environment. The goal is to eliminate ambiguity through overlapping sensor types. This is a stark contrast to Tesla, which, since 2022, has gone all in on vision first, arguing that cameras plus incredibly smart AI can replicate and eventually surpass human visual processing.
And the most immediate consequence of that sensor choice is cost, right? That dictates everything else.
Absolutely. Tesla's FSD hardware package for HW4, the computer, the cameras, it's estimated to cost maybe around $1,500 per car. Relatively cheap. Waymo's sensor suite with all the high-end LiDAR and radar, estimates put that closer to $120,000 per vehicle.
Okay, $1,500 versus $120,000. That's a huge
It's
difference.
astronomical,
Yeah.
and it fundamentally shapes their business models. That high hardware cost essentially forces Waymo into a more constrained operational model. They focus on specific, well-defined urban areas like parts of Phoenix or San Francisco that they meticulously pre-map in high definition. These are their geofenced service zones.
Because they need to maximize the utilization of those expensive assets within a controlled environment.
Right. Whereas Tesla, with its low hardware cost, is aiming for the opposite, mass market deployment. They want FSD potentially in every Tesla, capable of driving anywhere, enabling a global robotaxi network eventually. Adaptability over containment.
The sources use an analogy. Tesla is like biological evolution, learning from the messy real world, adapting, sometimes making mistakes, but getting smarter overall. Waymo is more like engineered evolution, meticulously designed, prioritizing safety through redundancy, but perhaps slower to adapt outside its design parameters.
That analogy holds up really well, especially when you look at how they integrate reinforcement learning.
How does Waymo use RL compared to Tesla's deep end-to-end approach?
Tesla, as we discussed, uses end-to-end RL. One big, or MOE, network handles everything from seeing perception to predicting what happens next to deciding how to drive control. RL optimizes this whole chain together. It allows for that organic discovery of complex, holistic driving strategies. The potential downside is that complexity can sometimes lead to unexpected behaviors, but the upside is rapid, adaptable learning from real-world chaos.
Okay, so Waymo must be more cautious, fitting their redundancy philosophy.
Exactly. Waymo uses what the sources describe as modular RL. Their system architecture is more compartmentalized. Perception is largely separate from prediction, which is separate from planning. RL isn't used to train the whole system end-to-end. Instead, it's used more surgically to fine-tune specific behaviors within that structured system.
Like using RL just to make lane changes smoother, or to optimize navigating unprotected left turns.
Precisely. They might use RL to refine the parameters for a specific maneuver, making it feel a bit more natural or efficient, but it's done within the context of their existing, heavily rule-augmented, safety-focused system. The priority is flawless predictability and minimizing any potential instability that end-to-end RL might introduce.
So, engineered refinement versus holistic evolution.
That's a good way to summarize it. Waymo's approach guarantees reliability within its known operating domain, but It might be inherently slower to adapt or generalize to entirely new environments or radically different situations compared to Tesla's approach, which thrives on diverse data.
Let's talk outcomes. How do the performance metrics stack up reflecting these different philosophies?
Well, Waymo currently leads in terms of deployment level. They operate fully driverless, level 4 services within their geofenced zones. Tesla is still officially level 2 plus hour, requiring driver supervision, although V14 is clearly pushing towards level 4 capabilities.
And safety. Waymo has impressive stats in Phoenix.
They do. Within their controlled environment, Waymo's safety record is remarkable. They reported something like 92% fewer injury-causing collisions compared to human drivers in the same area. Their driving style is famously conservative, very rule-bound, prioritizing safety above all else, which is exactly what you want inside a geofence.
Okay, so Waymo wins on proven level 4 operation and safety precision within its zone. What about Tesla with V14?
Tesla, especially with V14, leads on naturalism and scale. The deep RL approach is designed to produce driving behavior that feels more fluid, more human-like, that sentient quality we talked about. And obviously, Tesla's scale is orders of magnitude larger, learning from millions of cars driving billions of miles in wildly diverse conditions globally. Their metrics focus on achieving superhuman safety on average everywhere, not just in pre-mapped zones.
But the trade-off for Tesla is complexity and edge cases.
Potentially. The vision-only system, even with advanced AI, can sometimes be momentarily confused by extreme weather, weird lighting, or highly unusual visual occlusions in ways that Waymo's redundant LiDAR radar system might handle more robustly. Tesla's system is constantly learning to overcome these, but the complexity is immense.
So boiling it down, Waymo uses expensive hardware redundancy and detailed maps to eliminate ambiguity and guarantee safety in a limited area. Tesla uses relatively cheap hardware, but demands its AI become incredibly intelligent, using MoE, Deep RL, massive data to master ambiguity and adapt anywhere.
That's the core strategic difference. Waymo is selling certainty in a controlled premium service. Tesla is selling scalable adaptive intelligence for the mass market, betting that its AI can eventually become safe and natural enough to deploy globally at low cost. FSD V14 is the moment Tesla seems to believe its adaptive intelligence is getting good enough to challenge Waymo's safety claims, but with the potential for vastly greater scale and application.
It's a fascinating race with two very different, very powerful approaches. The level of AI sophistication needed for either path is just mind-bending. Hashtag tag 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 outro.
Wow. Well,
Okay, we started with that one provocative word, sentient, and we've journeyed through reinforcement learning, mixture of experts, billion parameter models, and the strategic battle for the future of driving. If we take a step back from all the technical details, what's the single most important thing for people to understand about this shift to FSD V14?
I think the real takeaway is this transition point. FSD V13, despite its complexity, was fundamentally about achieving highly competent mechanical automation, following the rules, executing maneuvers precisely. V14 represents the deliberate push towards behavioral intelligence.
Moving from just physics to psychology almost.
In a way, yes. Using deep RL to create a machine that doesn't just calculate trajectories, but seems to understand, or at least convincingly simulate understanding, the social context, the implied intentions, the unwritten rules of the road. If v14.3 delivers on that sentient promise, even metaphorically, it means the machine is starting to feel the road, not just drive on it.
And that feeling that behavioral intelligence is the key to unlocking the ultimate prize, isn't it? The robotaxi network.
Absolutely. It's the psychological hurdle. For mass adoption of fully unsupervised vehicles, people need to trust them. They need to feel natural, predictable, safe, not just statistically, but intuitively. If FSD V14 can achieve that sentient, trustworthy feel,
It clears the path for people to actually use a robotaxi without fear or hesitation.
exactly. And that unlocks the enormous financial potential. Analysts like ARK Invest keep talking about the potential $5 trillion valuation for Tesla if they can successfully deploy a large-scale, profitable robotaxi network. That value isn't just in the hardware. It's overwhelmingly in the scalable, RL-driven software stack FSD V14 and beyond, running on millions of vehicles.
But it's not a done deal yet. We have to inject some caution. What are the big roadblocks still standing in the way, even for a potentially proto-sentient AI?
Well, first and foremost, regulatory scrutiny. The NHTSA, the National Highway Traffic Safety Administration here in the U.S., and similar bodies globally are watching very closely. They want hard data, objective proof of safety across diverse conditions, not just anecdotal evidence or internal metrics. The marketing language, especially full self-driving and now sentient, is under constant examination.
They need to be convinced it's truly safer than humans, consistently.
Right. Second, there's the persistent issue of Musk's timelines. Let's be honest, full autonomy has been promised next year, almost every year since about 2016. Scaling these incredibly complex AI systems from simulation and testing to flawless real-world deployment across millions of cars is astronomically difficult. Delays are almost inevitable.
And maybe a third concern, the risk of people overtrusting it, anthropomorphizing the car.
That's a really interesting ethical point the sources touch on. If the car feels sentient, like a partner, do people become complacent? Do they stop supervising appropriately? Does it blur lines of liability if something goes wrong? And could it lead to weird emotional dependencies on the machine? These are societal questions we'll need to grapple with.
Definitely issues to watch. But the underlying technology, the MOE scaling, the sophisticated RL reward tuning it, clearly shows the capability is advancing at an incredible pace.
Yeah.
This idea that RL is teaching cars not just how to drive, but how to anticipate, how to interpret intent, it changes the game.
It really does. And it leads to a fascinating final thought for you, our listeners, to ponder.
Lay it on us.
If your car, running FSD, V14 or beyond, trained on billions of miles and optimized by RL, starts to understand your specific driving habits. Maybe it knows you tend to take that corner a bit too fast, or that you hesitate too long at certain merges if it knows your patterns better than you do.
Okay.
And it begins to subtly adjust its own behavior, or maybe even provide feedback to nudge you towards safer, more optimal driving when you are supervising or driving manually. When does that superior machine performance stop feeling like just a tool you're using?
And start feeling like
Wow.
a coach, a partner.
Exactly. When does that seamless, data-driven collaboration, where the machine might genuinely be improving your own skills, blur the line between a utility device and something closer to, well, a companion that helps you navigate the world more effectively?
Wow. When the car knows you better than you know yourself on the road.
Yeah.
That is a truly stunning thought to end on as these systems evolve from mere automation towards genuine intelligence. A perfect place to wrap up this deep dive. Thanks for joining us.